Now I'm going to use a bit time in the video to elaborate time shifting and time scaling, because it could be a little bit tricky, so that you can go back home to watch the video again to understand this issue in a much more detailed, thorough way. Now, shall I just remind you the time shifting from gt to gt minus 1, we simply replace t by t minus 1, and then for time scaling, and then from t to t minus over a, we simply replace gt into gt over a, right? So you must be careful to know the difference between gt over a and gat. I'm not going to spend time here. You can refer back to the handout, which is much more easier. Now, after we realize that, then I just trying to start from our handout here, right? For such a waveform here, right? For such a waveform, it starts from -1 and 1. Okay, then this is gt, right? Then we like to transform it into what? We like to transform it into g minus 2t minus 1. Well, I'm trying to show you that there are two ways in doing that. There are two different ways in doing that. First, what you can see is, first, I like to do it from time scaling first. Time scaling. So I just time scaling by -2 t. That means to flip it into negative, and then also to compress it by 2 times. So it was 1, 1, then it will become -0.5 to 0.5. Okay, this is time scaling. Then after we've done this job, then we can do one more job, is by time shifting. Then this time we are going to replace t by t plus 0.5. By doing that, t plus 0.5, that means we are going to shift this axis into the positive somewhere here. By shifting that somewhere here, so we will obtain such a thing. That's become 0, that's become -1. So we've done the job. So this function will become g minus 2t. Mind you that because we are going to do the time shifting, so the whole t have to replace by t plus 0.5. So to write t plus 0.5 right here. So this becomes g minus 2t minus 1. This is what we want to have. Then we can also obtain it by doing another way. Doing another way is, first we do by time scaling, time shifting, t minus 1. By doing that, because we shifted by -1, that means we are going to shift the thing to this. So we are going to have the waveform in such a way, we shift the y-axis to -1. So 1 will become 2, this one becomes 0. Okay, pretty straightforward. Once we have done that, then the second way is we are going to do time scaling. This time is time scaling by -1, because we would like to flip the thing over there. By flip it over there, then we will become something like that. So this one become minus 2. Then our function will become g minus t minus 1. Okay, now the last step is we like to compress it. So we are going to do it something like that. Then this one become minus 1, 0. So this one will become g minus 2t minus 1. Now, so basically, when you compare this and that, they are the same. But we are doing two different processes. Now here, we can refer to page 25 of our handout here. I like to show you a little bit tricky things between using time shifting and time scaling again. Now, suppose if you have g, t, then shift by minus t lot, then we'll get gt minus t lot here. Then if we go into scale it, scale by what? Scale by t over a, then we'll get, replace t by t over a, then we'll get gt over a minus t lot. Now, I'd like to say that this one is not the same of gt minus t lot over a. They are not the same. Here, I'm going to show you, right, gt, then if you shift it, time shift by what? By minus t naught over a, then our function will become gt minus t lot over a. Okay, once we have done that, we scale it, scale by t over a, then our function will become gt over a. We just replace this t by t over a, the same t naught over a. Okay, then this is exactly equal to gt minus t lot over a. Now, this and that one is equal, but this one and this one, they are not equal. So I'm going to show you how we can actually obtain the waveform. Okay. Now, suppose if we have a function gt, okay, in such a way, very simple function. Sorry. Right, this one from minus half to positive half. The y-axis is here. Okay, then with first time shifting, so I made it into gt over 4. That means it's going to expand by 4 times. So the waveform will become, by 4 times, minus half will become minus 2. Positive half will become positive 2. The neutral axis is still here. Okay, so we've got this one. Then once when we've got this one, then further to do it by time shift. Right, time shift. So this time we're going to try to do it by gt plus 2 over 4. That means we are going to replace time shifting, replace t by t plus 2. Now, so we are going to do a little bit time shifting here. By doing the time shifting, that means we are going to shift it by 2. In doing that, that means we are going to move the axis here into this direction by 2. So what we are going to have is minus 2 will become minus 4. And this is our waveform. So this is the function g t plus 2 over 4. Now we are going to do another function here to see how it works out then. Now gt the same minus half, positive half, or maybe I just move it to the other direction because we need more space here. Okay, gt is here from minus half, positive half. Then we're going to do time shift. Become gt plus 2. If you're going to do time shifting here, okay, try another color. So that means we are going to move the axis to this direction by 2. So this one will become minus half plus 2. So we are going to have the waveform is something like that. This one will become minus 5 over 2. And this one become minus 3 over 2. Okay. Then after we've done the time shifting, then we can do another scaling. Scaling t, we move it, replace the t by t over 4. Then in doing that, so we will multiply this t by t over 4. Okay, so our function will become g t over 4 plus 2. Okay, so what you can see is, what you can see, this one will be multiplied by 4, then will become minus 10. And this one will be multiplied by 4, will become minus 6. So our waveform will become something like that. Minus 10, and this one coming to here, minus 6. Then the function is g t plus 8 over 4, or just like this one, g t over 4 plus 2. Now then, what you can see, this function is not equal to the same as that function. Then somewhere here, somewhere there, somewhere here, somewhere there. This demonstration shows you the trick of doing the time scaling and time shifting in different ways. Then you have to be very careful to do it step by step.